Okay, welcome to Energy Transfers 4.6 to 4.7. We're going to learn today how do you stop energy from transforming. We talked in the last lesson about what happens when energy transforms. It does work, or something does work in order to transform the energy. So today we're going to look at these three keywords: conduction, convection, and radiation. If you can answer this learning intention, you should be able to describe how energy transfer may take place by conduction, convection, and radiation, and explain the role of convection in everyday phenomena. So we're going to look at a radiator in a room, but you should be able to do it with absolutely anything if you understand it. So the first thing you're going to do for me in your books, but then also on the boards around the room, is what does a solid, a liquid, and a gas look like? So particle theory is all about explaining the properties of solids, liquids, and gases by looking at what the particles do. And that's what we're really going to look at with conduction, convection, and radiation. So before we start, let's have a think about what a solid, liquid, and gas looks like. So you're going to put those in your boxes, in your books, and on your boards. We'll talk about that at the end of the lesson. Okay, so these aren't particularly good models, but I was hoping you would look at something like this. We'll talk about these models later. Okay, so conduction. And we think about in your groups or by yourself, why is this pan boiling? Why is the water boiling? The water is inside the pan, but the pan is on this. This is an induction ring, uses currents to make it hot. So we're going to think about conduction. So conduction, this, if it's in a red box, goes in your books. Conduction is the transfer of thermal energy through a substance without the substance itself moving. But what does that mean? Well, throughout the lesson, I'm going to do a demonstration every now and again. I'll have this one set up, so if you want to come over, you can have a look at it. There's lots of demonstrations for conduction, but this is one of them. I want you to try and think, do some research, and try and think. This metal bar has a paper clips attached to it by Vaseline. The heat of the Bunsen burner can melt the Vaseline as it makes the bar warm. Do all the paper clips fall at the same time? How do you know? So this is going to be one of your questions. So now those questions are on your desk. I want you to do some research, come over, have a look at the experiment, and then answer, and you'll get graded on this about all the paper clips fall at the same time. So I have a mark scheme on the next slide. So pause now, and then answer the question, and then come back to us later and give yourself a mark. So pause the video now. Okay, so hopefully you'd pause the video, and then if you have one of the points from below for your answer, you get a D. 2, C, 3, B, 4, A, and 5 for an A star. So this is how I wrote it out, and this is how I would think to explain it. Thermal energy causes the atoms in a material to vibrate because they're giving energy, so they are going to vibrate more. As they vibrate, they collide with the atoms next to them. This passes the energy along a material, because if you're vibrating and you hit the thing next to you, you'll start it vibrating. As they vibrate, they become hot, causing Vaseline to melt. The movement of the energy by collision of vibrating particles is called conduction. So if we go back to our definition, the transfer of thermal energy through a substance without the substance itself moving. Oh, I forgot you could watch that. You can watch that. So the substance itself doesn't move, it just vibrates. It stays where it is and just moves back and forth. This conduction of energy happens at different rates for different materials. So 5 of those would be an A star. All of them would be amazing. But you can also have solids as insulators. So solids that don't allow the energy passed on. So have a look at this. It's a very cool material called aerogel. Okay, so a couple of questions you can answer in your books. Describe how the structure of a solid is different from a liquid and a gas. Describe what happens to a single particle as it gains heat energy. Describe how heat energy is transferred by conduction. If you can answer those, you may be able to answer these. Conduction only happens in one state. Which one? These no need to go in your books. We'll talk about these during the next couple of lessons. How could you insulate an object to prevent heat loss by conduction? Not easy, but we'll start thinking about it. And why are baby chickens so fluffy? Why are chicks so fluffy? We'll have a look at that one as well. Now you need to pick out which you think are the 5 best conductors of thermal energy. Have a think now. Pause the video and have a think. Okay, so hopefully you paused the video, but you identified these ones. Silver is the best. Then we've got copper, aluminium, steel, and iron. You could do some research now about what might make these good or bad conductors. There's a follow-up question here. Which do you think would feel the coldest in a room? Okay, so convection. Convection is all about particles moving. So before we need to think about convection, we need to think about one thing: density. When you heat up a liquid or a gas, the particles move faster and get further apart, just like they do for conduction. But they can move a lot further apart for convection. So as they can move further apart, this lowers the density. So things like a hot air balloon, the air inside the hot air balloon isn't very dense at all, but the cold air around it is dense. So the hot air is less dense and it rises. So that's what causes a hot air balloon to move up in the air. That's what I just said. So how does the heat from a radiator reach us on the other side of the room? We're not going to look at a smoke box. We are going to use a radiator to show us about convection. So here we have the radiator. These are molecules of air. As they go towards, they're cool. As it goes towards the radiator, they heat up, which means now this is showing one individual molecule, but of course for convection, there's going to be lots of molecules. So all of them are going to heat up. And we just said if they heat up, it lowers the density, so they start to rise. So they'll start to rise. But as they start to rise, they go away from the thing that was heating them up. So then there's more heat coming this way, so they're going to get pushed over this side. And as they get further and further from the thing that heated them up, they're going to cool down. And we said when it cools, all the molecules get closer together, the air becomes denser, so they fall. And then they'll keep getting pushed this way. So eventually, all these will be moving quite quickly. All the molecules will have a lot of energy, so they'll start to heat up the entire room. So where's the best place to be if you want to get warm from a radiator? Above it. It's actually really inefficient to be on the other side of the room. Follow-up question. Why do we paint radiators white? Why are they always white? So what I want you to do now is have a look at convection in liquids on this video. What happens to the air particles in the room when they're heated? This is a bit of a summary. This is on your sheet again. Try and answer these questions. There is a mark scheme on the next slide, so pause it and then go and have a look. Okay, hopefully you paused it. The answers would be, so pause it, pause the video, go back through your answers and see if there's anything that you missed, see if there's anything that you can add to your answers. Okay, next thing, top right of your sheet is the starter for radiation would be, are these true or are they false? So pause the video, go through these, true or false. You're going to check them later to see if you were right. This is the visible light spectrum. How do you know that there is anything beyond this? How do we know about infrared? How do we know about ultraviolet? Well, it turns out that they actually have temperature. So we can measure their temperature. So infrared has a lot of temperature. It is the thing, it is the part of the spectrum which transfers a lot of a lot of thermal energy. You can actually prove things have infrared by old remote controls at home. If you point them towards your phone, you may be able to see the light, because if you have an older phone, it may not filter out the infrared radiation coming from it. This only really works with older cameras though. So far we've covered conduction, and we should have on our board 3 facts about conduction and the keywords. We've covered convection, and we should have 3 facts about convection and the keywords on the board. So we're going to start looking at radiation now. And this is a good diagram to show us the difference between them. So some of the uses of radiation, so we can see this house, and we can use an infrared camera to show us where the hottest parts are. So it is the chimney, the tops of the windows, which is what we learned from convection. Heat rises. And we can see they're losing a lot of energy from here, which is a bad thing. So you can see a deer. You can see where someone's been injured because blood is rushing to that area. And that would show an injury, so we can use it to diagnose injuries. We can use our knowledge of infrared radiation to keep people warm. If metals support insulators of heat, why is the athlete wearing a foil blanket to keep warm? Well, it's because infrared radiation can be reflected. We know that from our previous topic, from waves. It can be reflected. So if you want to keep the heat inside, any heat that you're getting, any heat you're generating, you want to keep that inside in your body. So if it's coming out, reflect it back. It'll keep you warm. Follow-up question, what would be the best color for the outside of here? So we can also use the keep warm, so you can see that no heat is escaping from where he has the hood on, or very little, mostly around here, but then his body is giving out a lot of heat. We cover our head because that's the area that seems to give out the most amount of heat. So which absorbs best? Have a guess. Okay, it was actually matte and dark. The darker the color, the more it was absorbed. Now we know that because black is an absence of color. So when you look at something black, it's because it's absorbed everything, all the colors. So that must be the best at taking in, absorbing radiation, because it lets very little back out. If you look at something black, it's black because it's absorbed all the colors. But it's got to be matte. Now matte means it's not shiny. So look at the desks in the classroom. These are shiny, so they would reflect a lot. Now something matte like your chair is not very shiny, so it would absorb more radiation because less is reflected. So then which is the worst absorber? Well, that would be shiny and light. Shiny, so it reflects, and it's very light, so like the whiteboards around the room, they're reflecting, and they're not absorbing much radiation. So have a think about this. Pause the video and have a think. We'll talk about this at the end. So let's go back and check those true or false. So I'm going to put them all up, and you can check whether you got them true or false. So now this is really good, because if you got them false, if you got them wrong before, now you're able to correct them and tell me why. So at this point, try and put 3 radiation facts on your board along with your keywords. Okay, quick quiz. Which directions does radiation travel? Well, travels in a straight line. Which will radiate more heat, black or shiny surfaces? It's black. Which will absorb more heat? Black. What's another name for heat radiation? Have a guess. It was infrared. Give 2 uses for this radiation. There's lots of uses you can use. Okay, so now what you want to do, last thing, we're going to try and apply all those things, conduction, convection, and radiation. And I want you to tell me how a vacuum flask works. Here are all the statements. I want you to put those in the right order on your sheet. On the next slide are the answers, so pause the video now, fill that in, and then we're going to check them. So pause the video now. Okay, hopefully you pause the video. This is the correct order. So you can see we're using, when particles are heated up, they move around. When they hit another when they move, they hit the other particle. So we've got some conduction. A vacuum contains no particles, so we're stopping convection and conduction, and there are no particles transfer the energy along. And we've got this silver coating to start reflecting the energy back into the whatever is in the vacuum flask. Okay, tell the person next to you the answers to these. Pause, answers on the next slide. These are your answers. Okay, that's it.